All right, our next speaker is Sirjan Kaur of University of Utrecht, and her talk is entitled Testing iRODS-based Applications Experiences with Yoda.
Hi, good afternoon, everyone. Welcome to UGM 2024. And it's my first time giving this talk. My name is Sirjan Kaur, and I work at Research Data Management and Services Department at Utrecht University. And I work as a software developer for Yoda, and I'm part of a team of 7 people who are all here somewhere. And we're all responsible for developing and managing the institutional service. Today, we will delve into the testing strategy that we have adopted for Yoda. But first, allow me to share some facts and figures about the university. Founded in 1636, we are one of the oldest universities in the Netherlands, with over 39,000 students coming from 118 different nationalities. We're also one of the largest. At the university level, we prioritize 4 strategic themes, and our interdisciplinary research approach is the top priority for the university. So whenever we are building research data management solutions, we make sure that it aligns to the needs of these strategic themes. So Yoda was first developed for dynamics of youth and then later expanded to meet the needs of other strategic themes. So a little brief introduction about Yoda. Well, it has already been covered early in the morning. Thank you, Eric, for stealing my thunder. So Yoda is an integrated research data management solution for researchers to preserve, share, and archive and publish research data during the research process. With Yoda, you can organize your research data and work according to FAIR principles. So Yoda was first started as an institutional service, which is still developed and maintained by Utrecht University. It was done to streamline research data management process, and it is fully developed as an open source software. It first went into production in 2015, and the first data package was published in 2017. Yoda has been presented here at the UGM quite a few times, and these are the key presentations that we had in the past few years. We also launched a Yoda Consortium in March 2023, which was done to have effective collaboration and on knowledge sharing and support the needs of the researchers and product development and improvement. Some statistics about Yoda. We have over 4 petabytes of data with over 13,000 users, and we're approaching 400 publications as of 2024 Q1. So Yoda is built on iRODS, with iRODS being its foundational component at the data integration layer. And on top of that sits our custom rules and microservices that implement our data policies and services at the configuration layer. These can be interacted with in three ways: web portal, network disk, and iCommands. And so now that we have a little bit about introduction of Yoda, we will now talk about the main topic of discussion, which is testing. So there are several testing strategies that differ from one organization to another, but these can be broadly divided into 3 main levels of testing: unit testing, integration, and end-to-end. Unit testing is done to the smallest unit of code and ensures code reusability and code quality, and also helps identify the bugs and errors earlier in the software development process. Once all the smallest units of code are tested, they are put together as a group, and then they're tested. That's integration testing, and it helps enhance software quality and reliability and security. For end-to-end testing, we simulate real-world user experiences with the application, and this helps in software reliability and user friendliness of the application, which in turn contributes to higher user satisfaction. So where does testing fit in our process? So we at Yoda use DTAP process. First we develop and then we test. And once we are done with the testing, we move it to the acceptance environment. And once the key users approve it, we move it to the production environment. There are several levels of testing that we use for Yoda. Starting from unit, integration, and API testing, which are also run on the containerized version of Yoda on Docker. And then we have smoke, UI, and manual testing as well, which we will see in detail later. So for this, we use different versions and plugins and also frameworks of PyTest and Python, which we will see in a minute. So before we move on to each of these types of testing, let's see how we use Docker. So Docker is a containerized, we introduced Docker somewhere last year, and we used containerized version of Yoda. And it was first developed for our local development, but then it also became a part of our continuous integration process. So we as developers, whenever we create a pull request, it goes through, depending on the code, it will run unit integration and API tests on it. So you will see a number of links on a couple of next slides. Feel free to browse them for more information. Let's start with unit testing, where you test the smallest unit of code. These are our automated tests, and we use Python unit test framework for Yoda portal and MOAI. MOAI is basically a service that offers harvesting facility and the flexibility to serve different metadata prefixes. And we also use PyTest for external user service. As mentioned earlier, these can be run as part of the GitHub workflow against Docker. And then we have a little bit of example here where we are running it locally. So we use unit test framework for Yoda portal. This is a part of the Yoda portal test cases. And these test cases, multiple test cases form a test suite, and these differ per Yoda component. For example, here we are just testing, we're trying to assert is the category name is valid or not. And if it matches with this format, then it asserts true, otherwise it asserts false, and then we can run these tests locally as shown. Moving on to the integration testing, we test multiple components as a group, and these are also automated, and we use a unit test framework again for MOAI and PyTest for external user service. These tests can be run through the integration rule in the Yoda rule set, as shown in the example here, where we're just checking if the user is admin or not. And then we create a rule, and then that rule can be called by the iRODS rule engine plugin for Python. And these can be run either in the development VM as shown here, or the Dockerized version of Yoda. For API testing is the same, it's automated testing, but we use a plugin called PyTest BDD, which is behavioral driven development, where which is a subset of Gherkin language. So we use given when then scenarios to test a particular part of the code. So for example, we created a browse API. And for that, we give it a scenario, say given the user is authenticated, and we hit the API with a certain collection. And for example, the collection names are shown here. So it will iterate through these collections and see if the result matches with the API response. And if it does, then it passes, otherwise it fails. Then again, these are also can be run locally and on as part of the GitHub Actions. UI testing is also automated. We use PyTest BDD, the same given when then scenarios here as well, but we also use a plugin called Splinter, which is a Selenium wrapper, which automates the browser actions. For example, in this case, we have an invalid user login. So when you're at the login gate, user enters the email and then incorrect username or password is shown. These are just snippets. I've edited just to fit on the page, actually. And these tests, it's important to note that these tests are run only locally. Moving on to the smoke and manual testing. Smoke tests are a subset of our API tests to confirm that the Yoda environment has been correctly deployed or updated, and they are usually run in an acceptance environment. And manual tests are run before the release of new software, and we do this mostly for two reasons. First, because there are still components where we have not automated, we have not good automated tests coverage yet. And the second reason is that because most of our tests is run in a development environment, that we need to make sure that the code runs properly in acceptance and production environments as well. Here is a sample test set that we give our key users for testing, manually testing. And you can see there is some overlap between this and the API test. For example, the first one, where we are browsing a folder. So these were all about the scripted and manual tests, which covers the basic test strategy that we have for Yoda. We've also ventured a little bit into the scriptless testing. So we have fuzzing and scriptless GUI testing, where fuzzing is where we put in unexpected inputs into the application and then try to see if there is any undesirable behavior. Scriptless GUI testing is the same, except it's only as part of the GUI. Okay, a little bit about fuzz testing. I think in the context of iRODS, there are two undesirable behaviors that we look out for. First of all, our custom rules and microservices. They should not crash the iRODS agent process. And second is the rules or microservices should give concise errors so that it makes the debugging easier. The general process of fuzz testing is identification of a target system. It could be a protocol, it could be an instance. And then this is an endpoint discovery. And once we have all the endpoints that we need to hit, then we determine the inputs because some of the endpoints might have inputs and outputs. So the program determines which are the inputs and which are the outputs by permutations and combinations. And then the program generates the first data and executes the test with that data. And so we analyze the system behavior, and this can be done through just observing the iRODS log, especially in iRODS case. We do have an experimental iRODS rule fuzzer that we use, and this is basically focuses on the rules that custom rules that we have, and it picks up those endpoints and then tries to run them with the fuzz data. For scriptless GUI testing, we use TestStar tool, which detects all the widgets that are on the GUI and then derives all the possible actions and randomly selects one and then executes the test. This could be, for example, as you see in the websites today, you randomly put an input, a text in an input field. And so the program will take care of it, and it would also randomly click on any button. So we are looking for undesirable behavior, which would be in this case, internal server error. And there are a couple of lessons that we've learned throughout this process. We prefer to write our rules in Python rather than in legacy rule language, so that it makes it easier to test the code automatically. Because we have a plethora of testing tools that are available that work with Python, so this improves the testability. Second is we prioritize writing the unit and low-level integration tests over API and UI tests. Say if we write unit and low-level integration tests after the development process, like pretty late in the process, then it might require some code refactoring, and that might take some time. So we prefer to write it first rather than later. Third, we feel that extracting domain logic from the code that performs iRODS functions into separate functions improves the testability. We can sometimes also use dependency inversion principle, where we use abstract classes instead of concrete ones to improve the testability. So in the future, we focus on enhancing the test coverage to include components that have limited or no automation, so that we can also decrease the dependency on manual tests. And second is we need to have more reliable UI tests. In our case, they're flaky in some systems, and we do not. That's the reason we do not have them in the continuous integration process. We did experiment a little bit about in Playwright, but I would love to know if any of you has any experience with that. Third, to be aligned with the Utrecht University's policy for digital accessibility, we also want to include accessibility testing in our strategy. So we are exploring ways to incorporate that. And that is the end of my presentation. Thank you all for listening.
All right. Do we have any questions?
This is dangerous. How much effort did it take to set up fuzz testing?
It is still experimental, and I think Sitze can answer that better.
Mike.
Yeah, it's fairly easy to get it started, but it's still a fairly experimental thing at the moment. Yeah.
Is this a custom tool that you built, or is this something that you found online, or standard tool that everybody uses for fuzzing?
I think it's one.
Yeah, it's basically a small Python tool.
Yeah.
Okay. Any other questions? Oh, we got one. That's some. It's Justin.
Okay, this is an online question. Did you cover all possible user interactions in the automated tests, for example, UI testing, or did you only aim test cases to test some main actions like data upload, download? And how many test engineers did you allocate for testing, or developers?
Yeah. So we used to have test engineers. I think we don't anymore. So we do that ourselves as developers. But we do aim to do mainly the for example, like you said, upload, download for UI, but we also try to cover a lot more user interactions than that. Hope that answers the question.
All right. Thanks.
Thank you.